These are considered special cases. Let me explain why. I've kind of mentioned this, but I haven't really gone over it to an extent. When you have an expression like this, okay, and we want to simplify this. Anthony, how do you think I would simplify this?
Put everything in there so the second power.
You think a squared minus 3 squared?
Or do you multiply everything by 2?
This is technically,
Oh, you would multiply everything by 2.
no, this is technically, anytime you see a binomial squared, or really anything squared like this really means a minus 3 times a minus 3. Okay? Anytime you see anything squared like that, it's really that binomial times that binomial, the exact same thing. So a minus 3 times a minus 3. I don't believe I need to go over how to multiply this. You could FOIL it or you can distribute it. Okay? Does that make sense? Let's say if we have something like that. Now that's a trinomial squared. Well, really, all that means is that trinomial times that trinomial. So if you wanted to actually express it out,
b2 plus 2x minus 3 times b2 plus 2x minus 3. That was easy.
okay?
Simple enough.
Anytime you see something squared like that, that's what that means.
As long as that's the homework.
I want you to make sure that you do not think of it as, think of this first one as a squared minus 3 squared. That is incorrect. If I could spell, that'd be good. That is incorrect. Okay, that's not that is not what that means. It's that term, those terms times themselves. Okay, so a minus 3 times a minus 3. Good? Those are considered special cases.
Why are they special?
Because they are.
My mom is
Solve this. What's my only option? I would have to distribute it, correct? Yeah, absolutely. So when I do that,
I knew that.
1x and
shh, that's going to give me x, and that's going to give me yx. Okay, that's simple distribution. Now, instead of starting with this is what I was kind of getting onto there. That's a 1 plus y. Instead of starting with this, we are actually going to start out with the second part. Okay? We're going to factor out 2 terms. You already know how to do it? We're going to find the greatest common factor of those 2 terms. Well, this one is very, very simple. The greatest common factor would be x. So if I factored it out,
Would it be the GCF because there's more X's than Y's?
this is really equal to x. I could factor out x plus 1 plus y. Okay? Those are the exact same things. So let's say if I had let's say if I had this. The greatest common factor of 10y and 5 is what? 5. What is left? It'd be 2y. And then you would have what? What would be left? Just be 1.
I knew that.
so do you have to put the 1 in there?
Yes, because why?
I don't know.
Because it starts out with 10y plus 5. The only way that I can get the exact same thing on the other side when I distribute it is if there's a 1 there. Think if there was a negative 1 there, it'd be negative 5, and that wouldn't be the same thing. Okay? Now let's say if I had... Stop tapping.
Oh, I get it.
Say if I had this. What's my greatest common factor of these two terms?
Hey, Josh.
What's my greatest common factor of those two terms? 3x and 9. Not everybody at once.
3.
Yeah, thank you, Kenny. Good job.
I didn't know the answer to the question. Sorry.
I didn't even know you asked the question.
Now, what is left?
X plus 1.
X plus 1.
Yeah, I got this down. I'll be asking him in a little bit how to do it.
Those are equal to each other. Okay? So my first step is to factor tree that out. Factor tree out 64. Okay? Now I'm going to circle the end of my roots right here. So I got a 2 here and a 2 here. I have another 2 up there. I got a 2 down here and a 2 down here. And then I have another 2. So, $64 is equal to
Somebody close that window. That's why it's cold.
So I've factored out, looks like 6 2s. So 1, 2, 3, not a 3, 4, 5, and 6. So I have 6 2s right there. Now let's go ahead and factor out the negative 40AB. And looks like we're going to go with green.
Which one will be on the outside? Is that what I did wrong?
So 40AB, so 4 times 10. And I have a 2 and a 2, thank you very much. So that's a negative 4AB. Now the 10. 5 times 2 is going to give me 10. You can make that, you can write it right there. Or I think it's probably easier when you write out the factored form, you can just write down negative 1. But yes, you can factor tree out a negative 1. That's perfectly fine. That's okay. So now I'm going to circle my end of my root. So I have a 2 and a 2. And I also have a 5 and a 2 right there. So I'm factor treeing the whole thing out. So I got a negative 40AB. And yes, now, because that's a negative 40, I'm going to write down, I'm going to factor out a negative 1 right off the bat. Because you know you can always factor out 1. If it's a negative, you can always factor out a negative 1. So I have 3 2s and a 5. So I'm going to write down 1, 2, 2, and a 2. I also have a 5. Now I also have A times B. Now, next up, let's find that greatest common factor. So let's see which ones I have in common. I have a 2 there and a 2 there, a 2 there and a 2 there, and a 2 there and a 2 there. That's the only common factors that I have. So I have 3 2s. So 2 times 2 gives me 4. And then 4 times 2 is going to give me 8. Now my last thing I need to do is see what I have left. For the 64, what do I have left? 2 times 2 times 2. Yay. For the negative 40AB, I have a negative 1, a 5, a A, and a B. So that's all combined going to be negative 5AB. And you're done.